Hello and welcome. Have you ever wondered just how fast life happens at the molecular level? Today, we're going to dive into the world of enzymes and uncover a key concept that measures their incredible speed, KCAT. First, let's quickly remember what enzymes are. They are biological catalysts. They speed up chemical reactions in our bodies without being used up themselves. To understand how fast they work, scientists often measure something called Vmax. Vmax stands for maximum velocity. Imagine a factory full of workers. Vmax is the maximum number of products the entire factory can produce in an hour when supplies are unlimited. In biochemistry, Vmax is the maximum rate a specific concentration of an enzyme can work when it is completely flooded, or saturated, with its target molecule, the substrate. It tells us the overall speed of the system. But what if we don't want to know about the whole factory? What if we want to know how fast a single, individual worker is? That's precisely where KCAT comes in. KCAT is also known as the turnover number. It is one of the most important numbers in enzyme kinetics. It tells us the maximum number of substrate molecules a single enzyme molecule can convert into product per unit of time. It's the intrinsic speed of one enzyme molecule working at its absolute fastest. Think of it this way. If Vmax is the total number of pizzas a whole pizzeria can make in an hour, KCAT is the number of pizzas one single chef can make in that hour. The way we calculate this is actually quite simple. The formula is KCAT equals Vmax divided by the total enzyme concentration, often written as ET. You take the maximum rate of the whole system, Vmax, and divide it by the number of enzymes you have, ET, and you get the rate per enzyme, KCAT. The units are usually per second, meaning events per second. So, a KCAT of 1000 per second means one enzyme molecule can process 1000 substrate molecules every single second. This is an incredibly useful value because it's a constant for a specific enzyme under given conditions. It allows us to directly compare the catalytic power of different enzymes. For instance, the enzyme catalase has a massive KCAT, in the millions, because it needs to rapidly neutralize harmful hydrogen peroxide. Another enzyme might have a KCAT of just 10, because its job is slower and more regulated. KCAT essentially defines an enzyme's top speed, giving us a true measure of its catalytic potential. It's a fundamental measure of an enzyme's efficiency. So, in summary, KCAT is the turnover number, a measure of how many reactions a single enzyme can catalyze per second when it's working as fast as it possibly can. Thank you so much for watching and learning about this core concept in biochemistry. If you found this video helpful and want to see more simple explanations of complex science topics, please consider liking this video and subscribing to support the channel. Your support helps us create more content just like this. See you in the next one.